Hello everyone. We are going to talk about, this is 1.05, question number 5. So I was getting questions on this, so here, let's talk about it. So at constant volume, you cool a sealed air-filled container, the pressure reduces by half. Which of the following happens? So spaces between the gas molecules shrink, half of the gas leaks out, the number of collisions per unit area doubles, or the temperature of the air inside reduces by half. So let's go back and let's look at what we were given again. So at constant volume, you cool a sealed air-filled can. So right away, what can we take out? Half of the gas leaks out, right? It's sealed. So nothing's going to leak out. The pressure is reduced by half. So let's see, constant volume. So we got pressure and temperature, right? So volume's constant, so we're looking at Gay-Lussac's law again. So we've got pressure 1 over temperature 1 equals pressure 2 over temperature 2. So that's what we're looking at, right? So the pressure is, reduced by half. Which of the following happens? So spaces between the gas molecules shrink. Well, what do? The pressure got reduced by half. So if pressure, let's say, started at 2 atms and then it reduced to 1 atm, we know that pressure and temperature are directly related, right? So if pressure reduces by half, less pressure, what happened? Well, did the space between the gas molecules shrink? Did the number of collisions per unit area decrease? Or did the temperature of the air inside reduce by half? So we cooled it. It does tell us that. Let's look at what the lesson says. So I pulled this straight from the lesson. So according to Gay-Lussac's law, so if we're at constant volume, fixed amount, which we are, right? Any given temperature, they're moving. Remember what temperature is. It's that kinetic energy, right? So the visual that we did in CC, this might not apply, but if you were in CC and we looked at that visual with the temperature, that wasn't exactly correct. We were just kind of trying to think about it that way. So think about the temperature. It's that kinetic energy. So as it cools, that kinetic energy is decreasing. So those collisions against the walls start to be less, right? Because that kinetic energy starts to decrease. So they start to slow down, right? So as the container's heated, the gas molecules get more kinetic energy. So they move faster and they collide against the walls more, which then increases that pressure, right? So everybody visualizing that? So, and then in turn, because that force increases, if we were changing the volume would increase, etc. So, hold on, I'll move that down. So you can see here, they collide against the walls less frequently with less force, therefore that pressure would reduce, right? So think, when you look at these kind of things, think through exactly what's happening at that molecular level. The other thing in the lesson that I wanted to go over is we know there's a direct relationship, right, between the pressure and the temperature. So you can see right here, I don't know if maybe my pointer shows, you can see here, so let's say we were at 600, right? So pressure 600, it reduces by half, so it reduces to 300. What happened? Well, just by looking at this chart, you can see, sorry, that was temperature, excuse me. Pressure at 200 right here, reduced by half to 100, what happened to the temperature? And of course, temperature has to be in Kelvin. So you can see that direct relationship. Pressure reduced by half, temperature reduced by half, right? So for this one, we can see that the space between the gas molecules, that's not, remember, go back down here and look, we're not talking about space between them, right? We're talking about the kinetic energy, how much energy they have, how many times they hit the sides. So we can rule out talking about the space between the gas molecules. So the number of collisions double, or temperature of the air is reduced by half. So we cool it, the pressure is reduced by half. What happens to the temperature? So the number of collisions per unit area, if the collisions doubles, what would have happened? That would have meant the pressure increased, right? So if collisions double, pressure is going to increase. That's what creates the pressure. So that one doesn't even make sense. That's opposite. So if the pressure reduced by half, the temperature also got reduced by half. So you can see there with your nice visual too when you're looking at your graph. So hopefully that helped for this one, number 5. And if you have questions, let me know.